this reaction will challenge your notion of equilibrium. You'll see why here in a second. This is a classic reaction that's often used as a demonstration. It's called the Briggs-Rauscher reaction. It was discovered by a pair of high school teachers. And it's pretty cool because discovered this a while ago, and they still have not been able to explain exactly what you're about to see here.
What did you just put in that?
So there's 3 different solutions here, and I got to mix them in the right order, so I'm going to be somewhat careful here. The first one is a hydrogen peroxide solution. The second one is KiO3 in a slightly acidic solution. So it's a source of iodine. You should see, if I did this right, you should see a little bit of something here. Notice something?
Is it turning yellow?
Turn a little yellow, that's a good sign. Solution 3 is where the magic happens. Always. This is a solution of malonic acid, starch, and manganese sulfate.
Whoa.
Oh.
No way. No. Is it gonna go back?
Yeah.
So when it starts turning orange like that, what is known, right, is this is iodine. Iodine, you may know iodine solutions that you put on cuts and that sort of thing are kind of an orangish color. So the iodine is building up, and it builds up to a point. The other thing that's in there is starch, and you, those of you that have taken Bio 1 might have done a reaction where you use starch to detect iodine. That's the blue color. So here it's building up. Eventually it hits the right concentration, and then that starch indicator takes over and turns blue. But then the iodine concentration goes back down. You lose the blue color, but then it starts building up again. And eventually it gets to the point where it turns blue again.
I could watch this all day.
Unfortunately, it won't go all day. It does wind down after a while here. So the reason this challenges our idea of equilibrium, right, is that this is a what's often described as a clock reaction, like a grandfather clock reaction, right, where there's a pendulum that kind of swings back and forth, right? But so there's materials in here that again are swinging back and forth, right? The iodide is increasing and then decreasing, and then increasing and then decreasing. But that can go on because there's another reaction that's going on at the same time that's driving the whole thing forward. Okay? So just like in a grandfather clock, you got the weights, right? Gravity pulls the weight down, and that's what keeps the pendulum swinging back and forth. There's another reaction going on here simultaneously that keeps this other reaction swinging back and forth, and you put some stuff in to make the color change really nice. Now that reaction that's driving it forward will eventually run down after a while, and it will stop. And you might notice as it goes on and on and on, things start taking longer and longer and longer to kind of change back and forth. Well,
That
is
was
it the coolest chemical reaction you've ever seen?
Yes. The fact that it changed color like that is so cool.